maybe. Okay. Cool. Okay, we are now live. Okay, hi everyone. Welcome to this morning's session. My name is Dr. Richard Klein, and I am joined here by a number of other lecturers and professors in the School of Computer Science and Applied Maths. The idea of today is just to give you a little bit of an introduction to who we are and what's going on in the school. We'll give you a little bit of a sense of what the program is about, who the lecturers are in the course, as well as some of the other things that are going on in the school in terms of interest groups and various other kind of fun activities that are going on. Before we dive into all the technicalities of everything, the head of school and then the deputy head of school are just going to say hello and give us a brief message. And then after that, we will continue with the rest of the morning. Prof, do you want to take it away?
Thank you, Richard. I don't know if I need to show my face, but I'm wearing my Kaizer Chief T-shirts, and I don't want anybody to know that I'm a Chiefs fan. Anyway, I've declared that. Can I quickly go through to welcome you to Wits, and in particular to the School of Computer Science and Applied Mathematics. My name is Rase'el Omiteki. With a name like that, you can only come from the northwest of province of this country. I'm the head of School of Computer Science and Applied Mathematics. We have about 50 or so staff members in the school. So welcome to Wits and welcome to the School of Computer Science and Applied Mathematics. We all know that Wits is a top university in South Africa and in Africa, and we are aspiring to become the best research-intensive university globally, and with relevant or locally relevant programs that we do. I can assure you that with a computer science degree, just the first degree, we have 100% employment rate of our graduates. So really, you are at a very, very good place. You'll have to participate with us to make sure that you get the best of the best education in the country. Now, one of the best things that students need to do actually is to keep a very good academic record. What do I mean by that? I mean, you have to work hard, and every time you get any distinctions or you are an A student, there are certain things like awards, awards that you can get. You can actually have your fees being paid by the university if you're a very good student at some stage because of getting accumulative awards that the university offer. I don't know if you remember in 2015 that we had the campaign, The Fees Must Fall. You can have your fees literally falling if you work really hard. Now, your degree is of an N number of years, and in this case, it's 3 years. Usually, the university will allow students to do their degree in N plus X years, where X should actually be very small. We tend to go to X being number 2, but at some stage, we find some students really the X going to a very large number, and that becomes a serious problem. So there are certain things that I don't want to talk about here because I wish you all the best, and I'm very sure that you're all going to go through the system very well. The lecturers here will tell you exactly what the programs look like, what the courses look like. Now, in 2020, we had a very serious COVID problem, pandemic, and it brought so many difficulties. But I hope that even in the high school, you've been learning through your the online system. We're gonna go through that. The lecturers will tell you, but it will be very, very good to see you. And I'm sure that sometime we might see you around in campus when you have maybe a test or an exam or any other assessment that you need to do. Now, the one thing that online teaching and online learning has actually brought is cheating. The university will not tolerate any kind of cheating. By that, I mean, we sometimes we can help each other, But we cannot take somebody's work and make it as yours. That's academic fraud, and that's cheating, and that's very, very serious. Can you imagine if you're going to have to pass your whole degree through cheating, which means that you might be a computer scientist who does not know how to program at the end of the year because all you've been doing is cheating throughout the years. We wouldn't want to see that. We want to see people who are going to really make a difference in our country. Remember, we have interesting stuff in big data or data sciences. We've got interesting stuff in robotics, in machine learning. We've got interesting things that people are talking about the fourth industrial revolution. I know some of my colleagues in the computer science, they really don't believe that, but it's there anyway. So you are really at the right place at the right time to make sure that you gain as much quality education as possible. And I'm going to stop here and wish you all the best. My office is always open. If you have problems in your class, you tell your lecturer. If you don't find any satisfaction there, you tell your course coordinator. They'll tell you who the course coordinator is. If the problem is still difficult to solve at that level, it comes to my office. But usually now in our school, the problems never reach my office. So we have been having very good relations with our students throughout the years. And I hope that even this cohort, yourself this year, we're still going to maintain such a good relationship. Welcome to Wits. Welcome to the School of Computer Science and Applied Mathematics. Thank you.
Great, thanks very much, Prof. Prof. Vadapalli, would you like to say a few words?
Thank you, Richard. Can you hear me?
Yes, yeah.
Right. Welcome to the School of Computer Science and Applied Mathematics. Let me first congratulate you for making it this far, given the situation in the last 2 years. Just as Prof. Joel echoed his sentiments, we would like to make sure that you have a wonderful academic year in 2022. We would have loved to have this session face-to-face, but given the COVID situation, protocols around COVID, and also the problem with venues, we had to go with an online session. However, I would like to have, in fact, we would like to have your full support in the upcoming year. Be assured that we have a wonderful UG team in place. They have come up with a UG booklet that gives you all the relevant information regarding the courses and the structures that are in place, and also, the rules and regulations around general behavior. Yeah, so I think Richard and his team are going to talk more about this. So I'm going to stop here. Again, welcome and all the very best for 2022. Thank you.
Great. Thanks very much, Prof. Cool. Okay, great. So thanks to the head and deputy head of school. So that's just a brief introduction by them, just so you get to know them a little bit and you can get a sense of the structure of everything. Maybe a good, I'll just kind of run through everyone else who is in this meeting and just give you a little bit of a sense of who they are and kind of what they're doing, why they're on the call. And then as we get through the session this morning, we'll have a number of opportunities for everyone here to just chat and say hello and all of that. So my name is Richard. I am the undergraduate coordinator for computer science. And so, so all the different, the structure of the course and the way that things are put together, a lot of that coordination comes from me. And I'm also one of the lecturers. And so I will be taking you guys for Intro to Data Structures and Algorithms in the second semester. Also on the call, we have Dr. Steve Ovo James. He is going to be taking you for Intro to Algorithms and Programming. And he is also the first year coordinator. So he's the one who sent out an email to everyone about this session. So you'll have heard from him, and you will probably be seeing him in person later this week for your first lab as well. We also have Brandon Ingram on the call. who is the third-year coordinator, and he's also involved in some of the interest groups. He's one of the associate lecturers in the school and busy with his PhD. We also have Dr. Helen Robinson. She is the lecturer for DCS, and so again, she'll also be taking you then in the second semester, and she'll be teaching you some of the discrete computational structures and a little bit of logic and things like that. Following that, we have Dr. Ritesh Ajuda. He will be taking you for basic computer organization. So he'll also be lecturing you in the first semester, and you'll be seeing quite a lot of him quite soon. And then I think that's everyone. Oh, sorry, I see that Dr. Professor Ranchod is also here. Just added into the stream. So he is the postgraduate coordinator in computer science, and he also lectures a number of second year topics. So this is the main kind of undergrad team that you're going to be working with this year, and you'll meet a lot of us more often in person as we go on. Cool. Sorry, a bit of echo there. Cool, fixed. Great. Okay, cool. So from here, we just want to talk a little bit about the structure of the undergrad program, just to give you a little bit of a sense about what's in store for you this year. Let me see if I am able to share my screen properly. Share screen. Is that popping up? Yeah, great. So hopefully this is showing properly. And this is just the structure here of your degree coming up. This is the Bachelor of Science in Computer Science, which pretty much everyone here should be registered for. And this is, just to give you a sense of what the different modules in the program are and kind of what you have coming up. So this year, you should be registered for 4 computer science modules. You'll be taking basic computer organization and intro to algorithms and programming. Those are both in the first semester, and they take place in the at the same time in the first semester. So what that means is that on a Monday, you'll have a lecture, an online lecture session for BCO, and then on Tuesday, you'll have a session for IAP, and then those will alternate through in the first semester. And then going into the second semester, there will be lectures and labs and things for DCS and IDSA. The idea of some of these courses, each of the lecturers will give you a proper introduction to each module when you start up with them. But just to give you a kind of a brief sense of what they are, basic computer organization is here just to show you what the different components of computers are, to teach a little bit of logic and kind of how computers then achieve the things that they do, right? So in Intro to Algorithms and Programming, we're going to teach you how to code in Python, how to code in C++, and then how to use those tools, how to speak those languages in order to solve a bunch of different interesting problems. So you're going to learn that kind of programming and algorithmic level of thinking in IAP. And then the question is, how does that, how do those programs get converted down into something that a computer can actually run on its hardware, right? And that's what basic computer organization will show you, that you can, it will talk how binary works, how binary codes work and all of that, and how you actually get things accomplished on the hardware itself. Moving on into second semester, Intro to Algorithms and Programming, that continues with IAP, but it moves into a way of thinking where it starts to say, how do we solve problems efficiently? So if IAP is about how do we do the programming, how do we get the correct answer out of some algorithm, second semester then starts to focus on what does it mean for an algorithm to be efficient, and how do we organize our data in a way that we can accomplish tasks as quickly as possible. So that's the IDSA. And then finally, then in DCS, that one is discrete computational structures, and it's a little bit of discrete mathematics. And so, sorry, the fuzz are out to get me. So there's discrete mathematics, where the idea is to say, previously at school you will have done some calculus, and in calculus you do it's all about continuous numbers, right? And so if you have a graph, it's a nice smooth graph, and you can take a derivative at any point. When we talk about DCS, then what we see is that you can how do you deal with math where things are discrete? And so when we're talking about integers and prime numbers and things like that, how do all of those things fit together? Okay, so that gives you a little bit of a sense of what the first year is. Sorry, I've lost my, there we go. Also this year, you should be taking Math 1, so you'll be doing algebra and calculus, and then you'll also be taking computational and applied maths 1. And applied maths, that's broken into 3 different modules, and those 3 modules take place over the entire year. And you're likely to have a session just like this fairly soon with them. And so they'll explain how the applied maths modules work. And then finally, you should be registered for one other course. And that other course can be absolutely anything you want. It can be information systems or economics or physics or statistics or chemistry or a language or music or interpretive dance or whatever other first year level module it is that you would like to take. And really the main thing here is just for you to take something interesting, something that you think is exciting and different, and that will kind of broaden your degree a lot. You don't need to worry too much specifically about what it is. We promise that we'll teach you all the things you need to know to be a good computer scientist. And we'll teach you, you'll learn all the maths, you'll learn all the computing and algorithms and that kind of stuff. So really treat that 4th subject as something fun, right? Just something cool and extra that you can do. And then in 2nd year, I won't go through these in too much detail, but maybe some of the main things to point out. You'll be doing mobile computing. So in mobile computing, you'll be developing apps and building your own apps. And so in there, you'll have a joint project between databases and MC, and you'll literally be creating your own app with your own server and all of those things. So that's a really fun one to do. 2nd year networking as well, where you kind of talk about how the internet works, how different computers can talk to each other over networks, as well as analysis of algorithms. That then is the 2nd year version of IDSA, where you continue to talk about how to make algorithms efficient and how to be sure that they're giving you the results that you need for things. You would also do maths 2 as well as applied maths 2. And then in 3rd year, we start breaking off kind of away from the more programming and app development and those kind of things. And we move into some of the more technical and also some of the more fun things as well. So you'll see that in 3rd year, you can take machine learning, where you can learn a little bit about artificial intelligence, how to build machines and algorithms that can learn from data, and how to use neural networks and get computers to understand images and recognize things and all of that. So machine learning is a very, very strong focus in the school. And when Pravesh talks a little bit later, he'll also give you a little bit of a sense of what some of the machine learning things that are happening in the school are. We also do computer graphics and visualization, which is all about rendering. So basically, I would take a bet that a lot of the people who are coming in at 1st year now are doing computer science for one of 3 reasons. You want to do artificial intelligence, you want to do game development, or you want to hack, or all 3. And so machine learning helps you with the artificial intelligence. You'll do a bit of AI, both in machine learning and in advanced analysis of algorithms. So you'll do a little bit of artificial intelligence in each of those courses. Computer graphics and visualization is about 3D rendering. And the main project for that is that you have to build a 3D game. So that's literally the brief of it. So there are a bunch of technical things that you have to make sure you do. But at the end of the day, you get to build this really, really big 3D game with rendering and water and light and reflection and all of those different things. So yeah, so those are those ones. Parallel computing starts to speak a little bit about how how to use computers that are very, very large, that are like supercomputers. So if you have your laptop maybe has 8, 9, 10 cores in it, right? If you've got a really powerful one. But if you're talking about a supercomputer, you're probably talking about a computer with hundreds of thousands of cores in it. And so then that starts to talk about how do you use machines that are that big, right? That can solve all of these kinds of things. There's a software design project and software design, and that really teaches you how to manage computers or how to manage software development processes, how to go to a client, how to find out exactly what it is that they want, and how to then design really kind of complex pieces of software, how to do them in a way where you can maintain them over time and that you know what's happening when you've got lots of different people contributing to the same project. Yeah, so that maybe gives you a little bit of a sense of what some of these different modules are. We can obviously talk about them more in detail later on, but I think in the interest of time, we can move on from here. The other thing that I just want to mention is this letter that we sent out the other day that just gives you a sense of what the plan is what the plan for the year is with respect to COVID. So as Prof. Adepali mentioned, we are limited a little bit in terms of venue capacity because we can only have 50% of a venue at the moment. And so the idea is that you will be doing online lectures and you will receive all of that information through the Moodle system, which we can talk about a bit later. But you'll be doing online lectures where you'll receive videos and things from your lecturers. You will then watch those videos kind of in your own time or in whatever time that they tell you to. And then there will be various online activities and things like that for you to do. You will then be coming onto campus for in-person labs. And so once a week, you should be coming on campus. And depending on the size of the class and the way that the venues work, we might be splitting those into two different groups that alternate with each other and things like that. But your lecturers will tell you exactly how that works and how that will be managed. Okay. So that maybe just gives you a little bit of an overview about what the program is about, what some of the modules are that you'll see in undergrad here, and what the plan is for teaching now. From here, I'm going to hand over to back to Steve. And Steve can maybe then just take over from here with the plan for the rest of the morning, if that's cool.
All right, thanks, Richard. Hi, everyone. I know you guys wanted some thumbs up, so there's some thumbs up for you guys. So yes, I think Richard covered essentially the kind of plan for the entire year. And just to re-emphasize, because there have been a few questions about this, in general, all your lectures, this is speaking to the first years, if there are other people on this call, but so for first years in particular, it will be online lectures. Those videos will be asynchronous, which means it's not like a live stream where you have to be there at a particular time in order to watch them. They will be posted. You watch them in your own time. And then in particular for introduction to algorithms and programming, and going into the second semester, there will be in-person labs. So those will be like your practical component of the course. So for instance, in my course, it's about introduction to algorithms and programming. And what that means is, essentially we're teaching you how to program. I mentioned in the orientation videos, even if you've never programmed before, that's perfectly fine. That's what we're here to teach. And so those labs will be about, getting you familiar with programming, in person, in the labs. So that's the plan there. And as Richard mentions, those will probably be split into separate groups, just in terms of social distancing constraints and things like that. So that's kind of the overall structure. Richard also mentioned that I'm the first year coordinator. So again, if you have any issues in general with first year, many of you will have contacted me in terms of registration and things like that. Then I'm the person to talk to. All right. So just very quickly, we don't need to spend too long on this. We also have on this call the other lecturers for first year programs. So that's Dr. Ritesha Judah, Dr. Klein, Dr. Richard, who you just heard from, and Dr. Helen Robertson. And I think maybe if each of them could just spend kind of a couple minutes just introducing themselves and maybe saying a bit about how their course will run, we can maybe do that for the next little while. One thing I also want to say, because I did see a question in the chat, in terms of textbooks, so for most of the courses, you don't need textbooks, at least in computer science. Everything is online, everything is free. In general, a good strategy is don't go off and buy a textbook unless you're told go and buy this textbook, right? Don't go and waste money unless you're instructed to do so. Certainly for the introduction to algorithm and programming, there is no textbook, so don't go off and waste your money. You're of course welcome to buy textbooks if you think that would be beneficial, but certainly I won't prescribe anything. All right, so I think that's about it from me for now. So maybe we can hand over to Dr. Judah just to say a few words.
Thank you, Dr. James. My name is Dr. Judah. I'm a senior lecturer in the school, and I'll be your lecturer for Comms 1015A or Comms 1019A, depending on whether you're doing the full-time or part-time. Well, there's nothing different between the two anyways. So the name of the course is Basic Computer Organization, and this course is fundamental to all of the courses that you will be taking in your undergraduate curriculum and beyond. It's extremely important to know the structure, how memory is structured, and the different components of any computing device. Yes, I'm also the second year coordinator, but that'll be for your second year, not your first year. Your first year coordinator is Dr. James, and the undergraduate coordinator is Dr. Klein. So as Prof said in the beginning of this, our university is world-class, but also our school is world-class. You'll find that a lot of the academics, such as Dr. Klein, Dr. James, Dr. Robertson, Dr. Rossman, all of these people are experts in what they're doing. And it's really great that you're being exposed to these academics and their expertise, because if you're interested in taking a career in any of the domains that they're interested in, then you have mentors in your school, which is really interesting and very important. And also securing a seat to this program, I believe it's extremely competitive, because I think the school executive has actually increased the requirements. So it's more difficult to get into computer science now than it is to get into actuarial science. We also have a large number of applicants, and we just choose a small number of them. So well done to all of you on getting accepted into this program. You really do deserve it if you're here. Okay, good. So regarding cheating, so the prof did say something about cheating. Now I have to tell you, you're joining a school of computing experts. Okay, if you're going to cheat, then you better be bloody good at it, because you're going to get caught. And there are systems in place and softwares in place that are there to catch you if you are thinking about cheating. So don't even go there. Just run an honest curriculum. And also the penalties for cheating is also, Dr. Klein will talk about that. The penalties for cheating is just, it's just a fail, and sometimes exclusion. All right. So I just wanted to say that, just to tell you who I am, and I'll be seeing you in this slot. So this is the slot that BCO usually would run in face-to-face, but now that lectures are online, you'll be getting your lectures on Monday mornings, and you can watch them anytime in the day. But the tutorial is unfortunately a fixed time. It will be on Wednesdays from 12:30. And we will have a discussion about the times and stuff like that. It'll be posted to you on your email. So just to give you an idea of this course, my course Comms 1015. The lectures will be on Monday. Will come up on Monday morning, roughly at 8 o'clock. And your tutorials will be on Wednesdays. You'll get a timetable with all of these things as well. Okay, thank you very much. I look forward to working with all of you.
All right, great. Thanks very much, Dr. Ritesh. Maybe next we can quickly hear from Dr. Helen Robertson.
Great. Thanks, Steve. All right. Okay, so good morning. Hello, everyone. My name is Helen. As Dr. Klein mentioned, I will be taking one of your courses in the second semester. So I'll begin now by giving you just a rough sense of what we will cover in the course, and then some of the logistical admin details, and then I will just mention a little bit about my background and research interests and this sort of thing. So the course is called Discrete Computational Structures, as Dr. Klein mentioned. I think I've just gotten the pronunciation of that correct this year. We will begin, so in the first half, by covering some set theory. So we'll cover what sets are, some important operations and relations on sets, and we'll also learn some propositional logic and some first-order predicate logic, as well as some different methods of formal proof. Okay, so covering this will be useful in various ways. So as Dr. Klein mentioned, we'll be looking at computation involving discrete entities, whether these are numbers or other members of sets. We'll also see that some of the methods of proof can be used to prove the correctness of an algorithm. And we'll also see that databases can be expressed in terms of relations of sets. And so operations of sets can be used to manipulate data in data. Right, but sort of more importantly, what we will use what is covered in the first half of the course to understand and describe Turing machines in the second half. So I suppose many of you are familiar with this notion of a Turing machine. So this is a model of computation that we would, I suppose, consider to be an incredibly simple model of computation, but which is still currently thought that it's possible for such a machine to implement any known algorithm. So this is sort of theoretically interesting in various ways in terms of computation. And so we'll be using what we've learned in the first half, and we will learn how to describe or construct Turing machines to solve various problems. And we'll look at some of the theoretical puzzles or problems involved with Turing machines. Okay, so in a nutshell, that's pretty much what we will be covering in the course. In terms of logistics or admin, so as mentioned, the course runs in semester 2. So this is the whole of semester 2. The course code is COMS 1016A. I suppose this will be on all of the relevant documentation that you've received. As Dr. Klein mentioned, the lectures will likely be online, so it's likely that even by the end of the year, it's going to remain that the lectures are online. These will be posted online, but then we will have assessments and or labs every week or a couple of weeks in person. So there will be some in-person component. Okay, so I suppose just finally to mention a little bit about my background and research interests. So I'm trained in philosophy and logic, for better or worse. So I was trained both here at Wits and at UCL. And my primary research interests are in epistemology, which is really the philosophy of knowledge, justification, and reasoning. And I'm also interested in the ways in which this intersects with the various branches of computer science. I'm involved in teaching the ethics of data science and in some collaborative research related to this. So if you're interested in discussing any of these topics, and I also have to put in a punt, I hear that you have a course available. You can choose any level 1 course. So I have to put in a punt. You should take a philosophy course. This is the thing to do. But yes, if you're interested in discussing any of these topics, then I'd be very happy to do so. I think you'll be able to find my email address and full name on the staff site.
Great. Thanks very much, Dr. Robertson. Just to answer one of the questions in the chat about part-time courses and classes. So the part-time program, everything will be online in terms of lectures and tuts and labs. There will be a tutor to communicate with. Primarily that will be in an online setting, so we won't require you to be on campus in order to do labs and things like that. However, for things like tests and exams, then you would be required to be on campus. But for general day-to-day coursework, everything will be online in that evening slot that's been specified for the part-time. So you certainly aren't expected to kind of conform to the full-time in those slots. So that's just to clarify that. I hope that helps. If you have any questions, please just drop that in the chat. All right. Anyways, so I think we have now kind of heard from all the first-year lecturers, and so hopefully you're excited for those courses. I think next up on the agenda is to introduce Shan Pillay, who is the head of the Mathematical Sciences Support Unit.
Hi, my name is Shan.
Sorry, Shan. Your microphone is crazy noisy. It's not the background noise. I think it's the microphone. It's the actual microphone. Shan, do you have another microphone? Oh, cool. Let's see. Nope, still.
Okay, working now?
No, it's still really bad. Okay. Should we maybe continue with one of the others and then come back to MSL?
All right, sure. Yes, I'm sure Shan, when he connects, will be able to tell you all about it. But just to give you the background, the kind of MSS and MSL, which is where your kind of labs for computer science, for the rest of your undergrad and postgrad degree will be, is kind of like the key support structure for doing practical work and all those things. So we have like hundreds and hundreds of computers. At the postgrad level, we have hundreds and hundreds of GPUs for doing research and things like that. And Shan kind of heads the team that manages all of that infrastructure. So I'm sure when he connects, he'll be able to tell you all about that. All right. In the meantime, I suppose we can maybe head and come back to Shan when the mic is working. So maybe let's go to Brandon. Brandon is a third-year lecturer, but also he runs a number of interest groups that are super cool, and hopefully he can tell you something about those now.
Yeah, sure. Thanks, Steve. You guys can hear me, right? Cool. Yeah. So as Steve said, my name is Brandon, and I'm a third-year lecturer, so I probably won't see you guys for a little bit. But I do run a couple interest groups that are available to all undergrads, postgrads, everyone. Both of these I basically started with aid from other faculty members as well a couple years ago now. The first one that I started was a interest group to do with the AI found within video games. So how that basically works is I will talk to or present to students the different AI techniques that have been utilized in video games, from some classic examples within like Quake or Doom to some more modern cases like Horizon Zero Dawn or even God of War, for example. And along with that, I've also been trying to figure out how I can just use the group as a way of teaching video game development as well. So I've been running a few tutorials in Unity, starting from a very basic concept and like building up week by week to develop a fully fledged game. So that's been quite fun. I've been doing that through like live streams and that type of thing. The COVID situation has made things a little bit more difficult with meeting students, but we've been having quite a bit of fun on our Discord server. And all of this information will be like sent to you how to join and stuff like that in the coming weeks through an email. But yeah, we have a Moodle page, we have a Discord server. So you guys, if you're interested, can definitely join that. So that's the one interest group. The other one is called RoboCup, or I basically head up the Wits RoboCup team. And that's like an AI team that's looking to compete in an annual robotics competition by the same name, RoboCup. And it's basically a competition that looks to generate intelligent robotic agents to play soccer. So currently we're working in a particular, like a league within that structure. And this is a simulation league. So if you can think of like FIFA or something along those lines, a little bit more, robotics oriented than FIFA, we're basically looking to develop intelligent AI for our simulated robots to play soccer. So that's the secondary interest group that I'm currently running. So if you're interested in either one of those, you will be seeing information, shortly. And you can email me and join the team, connect with us on Discord, and we'll be looking to have meetings coming up in the next month or two. So yeah, that's a lot of fun, and you guys should look to join. I appreciate Steve or Richard for bringing up a quick example of some of the stuff that you can find in RoboCup.
Cool. Thanks very much. Thanks, Brandon. Yeah, RoboCup is so much fun. I think that if anyone is wanting to be involved in like a project like that, it's such a lot of fun to be in something like that. The team did really well last year. Was the best new entrance to the RoboCup Soccer World Cup. So well done to Brandon and the team there. Yeah, and something like this is just so much fun. It gives you a way to kind of apply all the things that you're learning in your main courses, but you can still, but it's something fun like robots playing soccer. The idea of RoboCup, I think the goal is 2050, where they're supposed to play the winners of the FIFA World Cup, and so it'd be robots versus humans. You can see at the moment robots are losing a bit, but hopefully we'll get there. I see that Shun is back. Do you maybe want to try again?
Okay, hi everybody. My name is Shun Pillay. I'm part of a team called Mathematical Sciences Support. And the main function of Mathematical Sciences Support is to run a very large laboratory called the T.W. Kambule Laboratories, which you can find at the Science Stadium. This lab is quite unique at Wits in that it's dedicated only to the mathematical sciences, of which computer science and applied maths is the largest group. There's a few things that we do. The first is basic teaching support by way of maintaining and providing teaching and tutorial venues. We do some research support as best as we can. We try and help maintain some specialist research labs. There's some really interesting labs in the building that you guys will learn about quite soon. A lot of these labs happen to be world-class labs as well, and we're quite proud of that. We do a lot of community outreach. About 20% of our year is actually dedicated to going out into high schools and promoting the mathematical sciences. So a lot of you guys, or some of you guys may actually have met a lot of the team members from Math Sciences Support, from the road shows and stuff that we've been doing recently. A lot of our time is maintaining the physical infrastructure of TW Kambule Labs. It's a very large beast and it's quite complex and requires a lot of attention, so we spend a bit of time on that. Where we can, we offer support to staff. We also support the undergraduate interest groups that Brandon's been telling you about. I think Brian Maestri is online. He'll tell you about another interest group called the High Performance Computing Interest Group. This one's been particularly successful, where they use supercomputers competitively. And this interest group has actually produced #1 in the world results on multiple occasions. So maybe Brian could speak to that in a moment. In short, I'd just like to welcome you guys to firstly a world-class school and a world-class lab. And this year we're particularly eager to get you guys into the labs because for the past 2 years, our labs have been a bit quiet due to COVID. And that's been a bit sad. So we're really excited to welcome you guys physically back into the labs. It's your guys' presence that makes TW Kambule special. In terms of how to get support from us, or how to contact us, we've introduced a new ticketing system that we rolled out this year. So there'll be a single support email address that you can use to communicate with us. We'll share that with you probably in the next week or two. Thank you, Richard.
Great, thanks very much, Sean. Okay, cool. I think from here, maybe it's good just to catch up a little bit on some of the questions that I've seen. There have been some questions about the part-time timetable and just how that will work. So at first year level, the part-time courses will be, so because all the lectures and stuff are happening online, it means that you're going to just have the same online videos as the full-time students. The full-time students will be going in for labs and in-person assessments and things like that on Thursday afternoons. For the part-time students, you won't be coming in for in-person labs because we're trying to save you trips onto campus. And so the part-time program will have online labs with your tutors. Because that group is much smaller, the online connection does work quite well. So you'll have an online lab with your tutors, and you'll only be coming in person to do assessment. Okay. But we will give you more information, and you'll have your own channel within the Discord where the part-time class can chat with your tutor and all of those things as well. And so, yeah, so there will be Discord servers for most of your courses where your lecturer will be able to post announcements. There'll be channels for all of the different type groups and things like that. You'll be able to talk to your tutors and talk to other people in the class and those kind of things. So those will be running as well, and you'll be able to get more information about how those things work. Okay. I see that Jamer has joined us. Welcome. She is here and is going to be talking a little bit about the Wits Development Society. You can take it away.
Okay, cool. Hi there, my name is Jamae. I'm a CS Honours student at Wits, and I'm in charge of a new interest group at Wits called the Wits Developer Society. Let's start by why we started this interest group. As it turns out, finding a job is about more than just getting a degree. Now, don't misunderstand me. Obviously, getting a degree is very important. That's why you're here. But growing on a personal level is important as well. Think of it like this. When you're competing against candidates that don't have degrees, you will be the clear winner. But when competing against candidates who have degrees, just like you will, this personal growth is what sets you apart and makes you stand out, which is very important when you're trying to look for a job. So how do we achieve this personal growth in a way that matters to employers? There are a number of ways you can do this, but the one that seems to be the most successful is just exploring your interests. With that in mind, you are incredibly fortunate to have ended up in computer science because we have a lot of small groups called interest groups where you can do exactly that. The interest group I'm here to speak to you about, as I mentioned already, is the Wits Developer Society. It has its main focus on preparing you for what the workplace will expect of you throughout the course of your degree in small little bits instead of having to do it all at the end once you've graduated. We aim to provide you with opportunities for that personal growth that is so critical to finding a job. We have events and workshops where you can engage with your peers on interesting topics in the software development landscape, and similarly, you can engage with companies. Navigating the job market and landing a job can be pretty daunting, but with us behind you, helping you build your CV, your LinkedIn profile, and your portfolio will make things seem a little bit less scary, especially since you'll have the network of other young developers to share your struggles with and to call your friends. We've partnered with BBD, BSG, Adapt IT, Retro Rabbit, among other large software development companies in South Africa. And we plan to grow our list of partners more in the near future. So be on the lookout for those new partnerships as well. Anyone can join our club, whether you're absolutely new to programming or quite experienced, and membership is absolutely free. All you need is an interest in development. In order to join the club, you can fill out our Google form, and then we'll send through our Discord link via email. Hoping to see you at our club Discord and at our events relatively soon. I'll send through our link tree in the chat, and then you guys can join as you want. but I can take some questions if anyone has any in the meantime.
Cool. So we'll keep an eye for questions in the live chat on YouTube, and then we can answer those questions there. But great, thanks very much. Appreciate that. Steve, do you want to take over again?
Sorry, couldn't find the unmute button there. All right, thanks, Jermaine, for introducing that interest group. Just so you guys know, that interest group kind of started a couple months ago. It already has hundreds of members already, because obviously that's a very important part of this, is in terms of linking you towards job opportunities once you leave the university, and really Jermaine has done a great job with that. So thanks for presenting, and again, any questions, please leave them in the chat, and I'm sure we'll be happy to reply to that. All right, before we move on, I just want to say that there've been some questions in the chat and there've been some jokes, but women in society, and especially in sciences, have a lot of issues with being objectified and things like that, and it's all fun and games until you start making people uncomfortable and feel unwelcome and unsafe. So please, can I ask just this once? I'm not going to ask again, that you keep your comments to be respectful, to be aware that your comments will make certain individuals uncomfortable. And that's not acceptable in society, and we don't accept that in computer science. All right, so moving on from that, I'm not sure if Senzo is with us. Senzo, are you here?
Hi, Stephen.
Hi, Senzo.
Hi, everyone. I'm here representing Brian and MSS. Brian is a bit camera shy, so he's asked me to talk on his behalf. One of the things that we do in the building, Shan did mention, is we manage some interest groups, some of which include HPC, cybersecurity, robotics, and to focus on just the robotics interest group, on the HPC interest group, we've actually managed an interest group that has come out first in the world, not in South Africa and not in just the African continent, but in the world 5 times. And we featured in the top 3 at least another 5 times. So the interest group is quite successful. The requirements in order for you to be part of that interest group is that you are either first year or second year. And the national the students that participate go to national competitions, and they get training in most of the time in Texas, and the international competitions are normally held in Germany. So that's one of our key focus areas and our key strengths. And not just on that interest groups, but even on the robotics interest groups, we tend to do some interesting things, which form part of our outreach projects, where we go to schools and showcase robotics to learners and interest them in robotics. I think that's it from me. Thanks.
Great, thanks very much, Senzo, for that. So yes, just to re-emphasize, people earlier were talking about, Wits being a world-class institution, things like that. That HPC competition in particular, it's an international competition that we've won many times in a row, and so we're pretty good at that. So if you are interested in that kind of work, working with supercomputing and things like that, they new students into that program for training and to compete in the competition from second year onwards, but they're looking for high achieving students, obviously academically. So if you maximize your marks in first year, as you should be doing anyway, that's a route into a very prestigious competition, and hopefully, fame and glory at the end of it. Well, relative fame, but you get what I mean. All right, great. So yeah, for that Senzo, we can maybe now move on. So I see Dr. Bao is in the chat with us. As Richard mentioned, she is the honors coordinator, and maybe she can just say a few words about that particular program.
All right, cool. Thanks, Steve. Hello, everyone. My name is Hairong. So for most of you, I believe this will be you're starting towards your first degree, BSc in computer science. Also, I believe that most of you probably have a plan to study towards an honors degree after you completing your BSc degree. So I'm going to talk a little bit about the honors program at the school. So currently, the school is offering 2 honors programs. One is honors in computer science. The other one is the honors in big data analytics. All right. So firstly, I would like to talk a little bit about what is the benefit of doing an honors degree. So I think that's probably, there's no need for me to explain on that. So just to mention 2 reasons. First of all, the first can be, so getting an honors degree will be able to elevate you towards a better job opportunities. And then another reason that for you to do honors degree is that it will give you an opportunity, open an opportunity for you to study towards a BMSc degree, not only at Wits, literally at any university around the whole world. Of course, I'm talking about the English-speaking universities. So that's just 2 reasons that you should consider doing an honors degree after you completing your BSc degree. And then, so another reason that for doing an honors degree, I think from my personal opinion, and then I believe most of my colleagues would also agree that the honors study is probably the most exciting year of studies in the university. Yeah, so I think this is mainly from the content perspective. So once you get to the honors program, just from the modules you will be exposed to, you have a large pool of courses or modules that you can select from. Like currently we have around like 16 to 18 courses in the course pools for honors programs. So you can select the courses from in AI and machine learning. For example, for AI and machine learning related courses, you have artificial intelligence, adaptive computing and machine learning, and computer vision, robotics, reinforcement learning, multi-agent systems, etc. And then from the computing perspective, we also have high performance computing. And from the data science perspective, you have data analysis and exploration, data visualization and exploration, discrete optimization, etc. So we have a large pool of courses that you can select from for your honors study. And then these courses are very much, even from the, so from the market perspective, I think so there's lots of employers, they actually specifically look for the candidates that they learned 1 or 2 other than some of these courses. So they are very, very the hot topics in the computer science field, I would say. And then also for honors, in the honors year, we also have a research project program. So essentially for that topic, you can apply what you have learned for your computer science degrees, that you can apply those knowledge to solve a real world problem. So it's those projects usually very, very exciting. We can solve lots of reinforcement learning problems, computer vision problems, image processing problems, and also some theoretically oriented computer science problems, etc. So from the content perspective, we have the honors program is really, really exciting. So, and then another point, of course, I need to talk about is how do you get into that program? All right. So for honors program, so both programs, computer science honors and big data analytics programs, they have been very, very, very competitive during the recent years, in the past few years, and I believe it's going to be very, very competitive in the next few years, and then probably next coming several years, or even a lot of years, hopefully. Because the programs are very, very competitive, we actually receive applications from universities all around South Africa, including the top universities such as UCT, UP, UJ, etc. And not only universities from in South Africa, we also receive applications from other African countries like Nigeria, Zimbabwe, Lesotho, Cameroon, etc. So even India, etc. So The programs are very, very competitive. And then also the number of the honors students we have been accepting over the past few years essentially doubled in every 2 years. Like in the past probably 3 to 4 years, so this year we actually reached a large amount of like around 100 honors students. I think this is a historically large number for an honors program, even compared to the other schools in the faculty, So obviously we cannot increase the number of honors students like this in the next few years, because that's simply beyond our capacity and so on. So what we can do, the option we are left with, that we are going to become more and more selective. So it means that it's more and more difficult to get into these programs. So, and then this program will become more and more prestigious. All right. So by prestigious means that, okay, for an employer, if he has an option of like several honors students from different universities, the Wits honors will become even more and more preferred. So that's prestigious. So if you are planning to get into the honors program in 2025, so my advice to you is that, okay, you need to work hard from now. So pass all your applied math, stats courses well above 50. All right, you have to try to aim at like about 70s, 80s, something like that. And then pass all your CS modules well above 75, like something like that. And then in that way, I'm sure you will have a better chance to get the place in the honors program in 2025. All right, so that's all I wanted to say. And then good luck with your study and my best wishes to you all.
Great, thanks very much, Dr. Bao, for students about the honors program and all the exciting things they can look forward to, in the future, the next few years. Maybe now let's switch over. I see Zara is in the chat. Zara is one of our students who was in 3rd year last year, and she runs a couple of interest groups that she can tell you about as well.
Okay, Steve, can you please share the slides I sent you, if you don't mind?
Sure, 1 second. Hang on.
While Steve is busy finding those slides, I want to just reiterate what Dr. Bao said there about aiming for high marks. A lot of people go into university with the goal of hitting 51%, so that you've got a little bit of room. If you do badly, you can go down to 50. That is not a good strategy, right? It is important to not only get your degree, but to get it with the highest possible marks that you can. When you go out into the job market, whether that's after undergrad, whether that's after honors or masters, people will want to look at your transcript, and they will look at your marks, and they'll see whether you got your degree with 51% in every single course, or whether you got your degree with 70s and 80s. And so you should definitely be aiming to do as best as you possibly can, just in order to improve your chances, both at work and in getting into other programs as well, right? So getting into honors, these days you need a good 70% to get in, and that's true also if you move into other programs and stuff as well. So the slides are here. Zara, you can continue.
Yeah, thank you so much. So I'm Zara. I'm still finishing my degree in computer science and psychology, so I'm busy with that. And then last year I was the head of the consulting club. So that's not something you've really heard of, probably in computer science. So here today I'd just like to tell you a little bit of what is consulting and why you should maybe consider it, especially since it's not something you typically associate with a computer science background. Can you go to the next slide, please? So yeah, consulting can be basically summarized as business strategy. Let's say there's a company like Takealot, and they're looking to compete with a business giant like Amazon. they'd call in a consultant to come help them come up with a strategy to actually, compete with someone like Amazon in the e-commerce space. So yeah, not the most exciting definition, but you basically help businesses solve their biggest problems. Next slide, please. But yeah, the perks are a lot more exciting if you become a consultant. So, maybe Corona and online learning has made you realize that online learning is not for you and you really want to go travel. Consultants get paid to travel all over the world, from the Americas to Europe to Asia and beyond. There's a lot of travel involved. So if you love traveling and you want to get paid to travel, definitely have a look at consulting. There's also quite a high salary. There's quite a high salary involved. So top firms will pay you about R500,000 with a 4-year degree once you've graduated. So this is more than most industries, including computer science in South Africa, from my knowledge. So if you are looking to make mega bucks, definitely look at consulting. And then the other two I've put here is networking and career advancement. And I'll come back to those in a bit. Can you go to the next slide, please? So yeah, these are some of the top firms internationally, and they're also in South Africa. And you can read them all for yourself, but I'm sure you've all heard of the equivalent, I'm sure you've all heard of the acronym FANG, Facebook, Amazon. So the equivalent of FANG in consulting is your Bain, your BCG, and your McKinsey. This is because the top employees in these companies go on to take top spots at big companies due to the networking and the career advancement they receive while being in these companies. So yeah, I'll give you some examples because I think that'll show that a lot better. So can you go to the next slide? Sorry, I know I keep saying next slide, but yeah, slides are a great way of just, making a speech more exciting. So yeah, so some famous alumni who started at these consulting firms and now have big roles in tech companies would be the CEO of Google, YouTube, HP, and eBay. They were all consultants. So, consulting, you might not think of it being associated with tech, but you can definitely use it in the tech space. Then we also have the CEO of Meta. And then we also have John Legend. I just added him in there because he'd be a recognizable face to everyone. I don't think if you are looking to improve your singing skills that being a consultant is going to help. So yeah, and next slide. So some local examples, just to show you that, if you go to the Joburg offices after you've studied at Wits, that you will still achieve quite a high rate of success is, we have Roelof Botha. He was at the McKinsey Johannesburg office. Now he's quite a prominent Silicon Valley investor, and he was involved with PayPal in the early days. Then we have Frans Kronje in the startup scene, where he made data profit after he worked at Bain for a little bit in the Joburg office. And just to show you that they are non-tech people, because most consultants don't go into tech. I just put them here because it is, for computer science students. We have Deo Adefulu. She has quite a senior position at Cook, and she started the Bain Johannesburg office. So hopefully that's kind of shown you the value of consulting, and that you can combine it with your computer science degrees. You can combine a business sense to actually make your own company. So next slide, please. So hopefully now you're asking, how can the club help me get, into consulting or, learn about consulting? And we can offer you 3 things. We can offer you notifications on opportunities. And what's fantastic is that from a first-year level starting, that these consulting firms do have programs open, which, I haven't really found with tech companies in South Africa. So if you are looking to get some kind of work experience and exposure to the world of work, definitely, look at the consulting opportunities available. Then we also will be doing events online and in person this year, where you can learn more about consulting and see if it's fit for you. Then we'll also be doing preparation workshops to help you apply, to help you prepare for interviews. So yeah, hopefully you're convinced now, you love to join the consulting club. Next slide, please. So membership is absolutely free, and you can sign up on our website. There's a Google form, and I'll also put the link in the chat. Then if you have any questions, you can put them in the chat, or there's a club email. Yeah, thank you so much. So that's all from me.
Great, thanks very much, Zara, for sharing that super interesting interest group. I think a lot of people will benefit from that as well, along with all the other interest groups that we've heard today. So that's great, and thank you for that initiative.
Just to jump in, there's a question that says, what are the requirements to join the consulting club and
so what's great about consulting, they take from any degree in any year. The only thing I'd recommend is getting high marks because it can be quite competitive. So guys, academics is very important. Please listen to your lecturers. And yeah, and we will be discussing, if you do join the consulting club, of, when you prepare your CV, what does a good CV look like for consulting? So we will cover that. Yeah, thank you.
But basically anybody can join upfront, right?
Yes, anyone can join upfront. So it's open to all years, all degrees. So it's the DevSoc actually.
Yeah, so it's the DevSoc. They're open to all years, all degrees. Just the main aim here is that you need to have an interest in software development, because that is most of what we'll be doing. And if you don't have an interest in software development, you'll find it rather boring.
All right, great. Thanks, everyone. Yes, and again, any questions, feel free to contact the relevant people, either in this chat for now or using those links that have been provided. So that's great. I think we are kind of at our very last speaker, so I'd like to introduce Dr. Professor Ranchod, who will tell us a bit about exciting research and postgrad opportunities.
Hey everybody, I'm Pravesh. Can you guys hear me? Okay, good. So before I start, I just want to touch on some general points. First of all, in this first lecture, I think Steve is being quite formal, but you'll find that in general, we often just ask students to use our first name. So for instance, I won't be Dr. Ranchod to you, I'll be Pravesh in general. And you'll have Steve and Ritesh and Brendan and Hirong, and you won't generally use our titles. And you may think this is just some random cultural thing, but I actually think it's a quite important thing. And what it emphasizes is that we don't require your respect because of our credentials or because of our experience. We just expect respect because you're supposed to extend respect to everyone, right? So I just want to reiterate what Steve said, that it's very important that you treat people with respect. In particular, treat each other with respect. I mean, everyone in there is worthy of respect, even the Chelsea fans. And on a serious note, we won't tolerate any abusive behavior, right? If there's any complaints about racist or sexist behavior, these will get fully investigated. Legal office will get involved. We don't want to see this sort of thing, right? As someone who grew up in the 80s and 90s, we glad we're out of that time, and let's stay out of it, right? Okay, so I think one question people often have is, what is research about? What is, why would I stay for postgrad? I've seen a comment that says it's going to take me like 10 years. Why would I study for another 10 years? I don't want to leave school when I'm old. Well, the important thing about research is that it's just about solving some particularly cool problem, right? What makes a problem cool? Well, first of all, it must be difficult. Otherwise, it would have been solved already, right? So there is that. But the other thing about these problems is that you can just pick something that you find awesome. So if you think getting robots to play soccer is the coolest thing, then you could very easily make your research about that. Okay, if you think having computers understand emotion is a really cool thing, you could do that. Now, because of this characteristic, because fundamentally you get to say, hey, what's the coolest thing I could possibly solve? It doesn't feel like it takes forever. I know that as an 18-year-old, if we said, it's going to take you 10 years to get to the end of a PhD, you're going, that's more than half a lifetime. But it doesn't feel like that, because basically what you're going to live those years anyway. You may as well live them doing something that is incredibly cool, right? In terms of the research that we do in the school, I think the biggest areas we have are machine learning, high performance computing, and theoretical computer science. When it comes to machine learning, the fundamental here is that we're trying to get machines that can improve as they do stuff. Okay, and we apply this to areas like computer vision, where we want robots to be able to understand video and images, and make sense of the world without humans having to do anything. And what I mentioned earlier in terms of understanding emotion is part of that. We apply machine learning in computer games, in healthcare, all sorts of things. Robotics is a big one. And you may have a question then of, well, how do computers learn? Like, I mean, it's fine, it's all good and well to say machine learning, but what does that mean? Well, I'll give you an idea of some of the more accessible ways. So one method we use is evolutionary computing, and at a very basic level, you can think of this as functioning very similarly to the process of evolution, where what we do is we start off with a population of programs that are meant to solve a particular problem. And then what we do is the ones that are really bad at it, we kill them. And the ones that are kind of decent at it, we let them breed and make a new generation of programs that are even better at solving the problem than the previous one. Okay? And whether or not you believe that evolution is something that happens in the real world, and you really should believe that it is, we find that this does work in algorithms. We find that this does result in improving algorithms. Another method we use is something called reinforcement learning. And this also is something very similar to what we see in real life. Reinforcement learning is, let's say we have robots playing soccer. What we can do with reinforcement learning is we can say, every time you score a goal, we're going to give you a reward. And every time you concede a goal, we're going to, I don't know, what's a bad thing we can do to a robot? I don't really know. We're gonna take away your lubricants or something. I don't know. And what we find over time is that the robots just naturally get better at playing soccer. So some of these techniques are inspired by the world, but also they're quite fun to get involved in, partly to understand how the world works and partly to make robots and computers do better at particular problems. When it comes to high performance computing, you can think of this as, how do we get computers to perform at a level you've never seen before, right? So one of the interest groups talked about it before, but basically, and I think Richard mentioned it in the discussion of parallel computing, is instead of having 8 cores, you could have thousands of cores, tens of thousands of cores, hundreds of thousands of cores, okay? And it may sound like, well, that means any problem should be easy, right? If I have one computer and this problem can more or less be solved by a computer, if I throw 100,000 computers at it, it should do really well, right? Well, the analogy I like to use here is, you guys have all worked on group projects. If your lecturer told you, hey, 6 of you can work as a group on this project, so I'm going to make the project 6 times bigger, would that make anyone happy? Probably not, right? You've probably found that in a group project, the project takes longer than if you just done it by yourself. And the reason is because you end up doing work someone else has already done, or communication and coordination takes a lot of time. And these problems exist in high performance computing as well. Getting computers to coordinate and communicate in ways that don't cost a lot of time is pretty difficult. There are also problems that are very difficult to share the work on, right? Sometimes you may find one computer is waiting for another computer to do its work before it can continue. And I want to just emphasize what Senzo was talking about in terms of the student high performance computing competition, which you guys can all get involved in second year. So, you have this international competition where teams from the US, China, Russia, Europe, universities from all around the world take part. And you've got this really prestigious university that dominates. And that's the problem with these international competitions, right? Is that you often get these incredibly good universities that just win the prize every year, and no one else gets a chance to really win. And that's us. That's Wits. No one else gets a chance to win this competition because it's ours. We dominate the thing. So high performance computing is a good area to get into. In terms of theoretical computer science, we have a lot of research going on in logic and in formal languages. And these are things that you'll see in your coursework. I think in DCS, you'll start seeing some of propositional logic. And in third year, you'll get an introduction to formal languages and automata. And these more theoretical aspects are often often the stuff that you might find the most fun. Before I stop, and I am about to stop, I just want to also talk about something that I think is quite important, which is that the fundamental characteristic of a computer scientist, in my opinion, is that we like to avoid work. We are extremely lazy people. Why I mention it is because there was a discussion earlier about cheating and about using other people's work and stuff like that. And I just want to emphasize what the lazy approach is in this field. And that's to make sure you pass your courses the first time, right? What's more work, doing a course once or doing it twice? I mean, clearly doing it once, right? Now, when you have a choice to, for instance, not do assignment 1, what you're making a choice to do is not learn how to do the stuff that's in assignment 1, okay? And all that means is you're gonna have to come back and learn it again. Let's say you manage to cheat your way into passing the course. Then in second year, you're gonna be like, how do I do these things? And you're not gonna know. And so you're gonna have to come up with ingenious methods for how to con us into thinking you've done the work, right? And then let's say you've succeeded in second year. You're gonna have to do that in third year. You're gonna get into a job situation and you're gonna have to find ways to con your boss. I mean, all of this sounds exhausting to me. I'm a very lazy guy. The easiest way to handle this is to learn to program so that you can do it, right? Do your labs because it's by far the lazy approach. Okay, I'll stop joking now. Thanks, everybody.
Great, thanks very much, Paresh, for that insight and for, in general, just discussing all the cool things that the students can look forward to. All right, I think we're out of time. So thanks everyone for being here. Thanks to all the students for sticking around. Thanks to all the staff and lecturers for joining us and telling everyone a bit about the school and how everything will work. So just quickly to wrap up, this week for first years, everything is online. The programming labs, which will be on Thursday, and I'll send out an email about that sometime today, exactly when you should come in for that. Everything else is online. For all other years in your third year, all online for this week, and you will hear more from your lecturers going forward. We covered textbooks, no textbooks required here at least, but you can go back in the video to see more of a discussion based on that.
So just confirming, third year lectures are happening this week.
Okay.
But no
third year lectures in person.
Yeah.
Okay, great. All right, and then for more information, if your timetable is incorrect or missing common subjects, please see the email that Richard sent out with the PDF. It has links to the computer science timetable. Use that as kind of the definitive guide to computer science lectures and tuts and labs. So yes, thanks everyone for joining, and we look forward to seeing you in class. Thanks everyone. Cheers.
Thanks everyone. Thanks for coming through. Yeah, and we're looking forward to seeing you. I hope your first week of term goes well, and good luck with calculus up next.